Hello, so I'll introduce you to this lesson. It's going to be sort of an investigation that you go through yourself, and then you'll be able to check your answers as well, just to make sure you've actually got everything correct. And if you didn't, that's all right. That's part of investigating. You don't necessarily get everything correct on the first try. Okay, so what we're going to do is we're going to investigate different areas of rectangles, and we're going to see how the length and the width compare to each other and what that means for the area of the rectangle. So in this first example, what I'm going to have you do is investigate a rectangle of perimeter 12. So that's going to be really important that we keep that perimeter basically constant as we check different values of width and length. So for example, we're just going to look at different widths of 1, 2, 3, 4, and 5. We're just using whole numbers because we like whole numbers. We don't have to, but it just makes our work easier. And what we want to do is we want to check what would the length be associated with that width. So just remember your perimeter is equal to 2 lengths plus 2 widths. So if you have a width of 1, and you have a perimeter of 12, what would your length have to be? So make sure you can calculate that out yourself. I will just actually include in here what it would be. So you'll have 5, let's say, for the first one. And then remember what your area is. And I'm going to do these first couple, but go through and do the calculations yourself. Because what I want to talk about is in the table, you will see this section called first differences. What does that actually mean? So a first difference is if you're looking at a table of values, it's just the difference between the two consecutive values. So we have 2 values in here, that's why I want to do the first 2. And the first difference is the second one minus the first one. So 8 minus 5, which is equal to 3. And essentially that shows you the change of value as you go down the table. So from the first one to the second one, we added 3, so that's our difference. And what we can do is we can keep track of that first difference and see how it's changing, and to see, if you reach a maximum area, which is what we want to find, to see basically when that first difference gets closest to 0. So that's the idea. So go through, find different lengths, find the areas, try to see what the length and width are like when you get to your biggest area, or when the first difference is closest to 0. All right. Then I also want you to go through, maybe you have an idea after that first table, go through and do a similar thing with a second one and see if that pattern continues. And that's going to be the idea is given a fixed perimeter, so that's what we have. In the first case, it's a perimeter of 12. In the second case, it's a perimeter of 14. And see what you need to create a maximum area. That's part 1 of the investigation. Part 2, and you'll see there's a quick little example question for you to fill out. So try that out yourself. I'll have the solutions as well afterwards. Part 3. Well, yeah, it is actually part 3 because there's 2 examples on the previous one. But this final part is now we have a little bit of a difference. You have a rectangular garden, but only 3 sides need to be covered. So you're still creating a full rectangle. So I'll draw it on the side here. Still creating a full rectangle, but one side already has, let's say, the materials. In this case, you're looking at edging materials, so it doesn't need to be covered. And so you only need to cover 3 sides. So we want to figure out how do we get the maximum area given that we only need to cover 3 sides. And we still need to make a rectangle. And we'll consider the side that's parallel to, let's say, that blue edge, so the one that doesn't need the material. That'll be our length. And we'll have 2 widths. All right. So what I want you to do is go ahead, figure out what the width would be given your length. Remember, you only need 1 length, but you have 2 widths. And then figure out the area. And then see where does the maximum area occur. and go through, answer these couple of questions and see, yeah, what's the sort of pattern, if there is one. So how do the length and width compare to each other when you get to the maximum area? And then there's a little example question for you to try out yourself and then to check with the solutions. All right, so go ahead and get started on that. And if you get stuck, you can always check the solutions afterwards.